Okay, so today we're going to be expanding on our inverse trig functions. So last week we actually created the inverse trig functions themselves, limiting the domain, and then talked about how to evaluate a simple inverse trig statement. Now we're going to be talking about when we put them together with our trig values and using the unit circle. Okay. One thing that you have to realize is that we've been doing inverse trig before when we did right triangle trig. So say this is theta, this is 6, this is 12, this is x. And when we went to go find angle measures, we first had to set up our trig function like this. Well, we have the opposite side and the hypotenuse. And then we did this. Sine theta is 6 over 12. And then we had to solve for theta. And what we would do is we put theta equals sine negative 1 1/2. Okay? When we were doing this, we were doing our inverse trig, and we just plug into the calculator, and we'd find that theta was, you get 30 degrees or pi over 6. Now, this right here, this is arcsine. So basically these, evaluating arcsine of 1/2 is the same thing as this. Okay, so we've done this before. So when we're looking for an angle measure, we use the inverse trig functions. So for instance, number 1. So the easiest way of doing this is to split it up into a couple pieces. So let's deal with the inside first, since we're doing a composite function. We have a function inside of a function. So this is asking us right here, arc cosine 1/2. So what angle measure is cosine 1/2? Okay, and that is at pi over 3. Remember, arc cosine will only give us back first and second quadrant values. And now, this is sine at pi over 3. What is sine at pi over 3? Well, that's the square root of 3 over 2. And that's our answer. So that's one way of solving this, where you evaluate the inside function first, then evaluate the outside function. Now, if you read it a different way, this is basically saying sine, right? Sine is saying this is the y value at pi over 3. So my original was saying, what is the y value at the angle where cosine is 1/2? Well, if cosine is 1/2, then the y value has to be root 3 over 2, because that's the way the coordinates from the unit circle work. So that's another way of looking at it. Okay. So let's look at the second one. Same thing, we're going to evaluate the inside, and then we're going to evaluate the outside. So this is tangent. Now the arcsine of negative 1/2. So that's saying, where is the y value negative 1/2? Well, the y value is negative 1/2 at a pi over 6. But since it's negative 1/2, that puts us at 11 pi over 6. Okay? Because remember, sine can only give us back first and fourth quadrant values. So technically 7 pi over 6 sine is negative 1/2, but it is not in arcsine's outputs in its range. Okay? And now, what is tangent at 11 pi over 6? And that's negative square root of 3 over 3. Okay? So it's really easy. If you know your unit circle, this becomes super, super simple. Okay? Number 3. So again, arc sine, cosine at pi over 2. What is cosine at pi over 2? That's 0. Now, we need to find what angle measure is sine 0. Well, where is sine 0? At 0. Okay. Now, number 4. Arc cosine. So this is going to be cosine. And arc cosine saying, okay, what angle measure is cosine 1/2? Well, cosine is 1/2 at pi over 3. And then this one saying, hey, what's cosine at pi over 3? Well, cosine is 1/2. Now, one thing that you have to realize is that arc cosine and cosine are inverses. So this was basically what we talked about back when we talked about inverses. When you take the function and you take its inverse, you should get back x. Okay? That's something that we talked about at the very beginning of the year. And in this case, absolutely, we get back exactly what we started with, 1/2. Now, the problem with the arc cosine is that it doesn't always work that way. Since it's got a restricted range because of the restricted domain, it doesn't always work that way. You can't just say, oh, these two are inverses, I get 1/2. And I'll show you what I mean in just a minute. Okay? But it's close. Okay? So next, arctan. So this is cosine arctan of 1. So this is saying, where is tangent 1? Tangent is a 1 at pi over 4. And what is cosine at pi over 4? That's the square root of 2 over 2. Okay? And the last example, number 6, and this is where you can get into trouble. Okay, so arcsine of sine at 5 pi over 4. If we use this idea of inverses, okay, and saying, oh, these two are inverses, so I should get back 5 pi over 4 because that's the way inverses work. That would be wrong. Because technically you should get back 5 pi over 4, but 5 pi over 4 is in the third quadrant. Arcsine will not give you back any third quadrant values. Okay? Arcsine will give me back a pi over 4, but not 5 pi over 4. So arcsine and sine at 5 pi over 4 is negative root 2 over 2. And arcsine will only give back the negative quadrant in the fourth quadrant, the negative values in the fourth quadrant. So this would be 7 pi over 4. Okay, so you got to be careful. Just because they're inverses, it doesn't necessarily work. If it were sine of arcsine, then absolutely. But since it's arcsine first and then sine inside, since arcsine only gives us back first and fourth quadrants, we'll never get 5 pi over 4 back. It'll give us back 7 pi over 4. So you kind of have to be careful. Okay, but again, none of this is going to be possible if you don't know your unit circle values. So if you haven't figured out a way to remember those, you need to work on that right away.